Have you ever wondered how light-speed travel could be possible? Imagine zipping through the cosmos faster than light, visiting distant galaxies in the blink of an eye. The key to such incredible speed? The Higgs distortion drive. This speculative piece of technology blends our current understanding of physics with a dash of sci-fi imagination to create a mechanism for light-speed travel. Intrigued? Well, buckle up, as we are about to embark on an exciting journey through the components of the Higgs distortion drive. Imagine if we could reduce the mass of a spacecraft to zero. Sounds crazy, right? But here's where the Higgs field modulator steps in. This nifty piece of tech, straight out of the pages of a science fiction novel, could potentially make this a reality. The primary function of this hypothetical device is to generate and control an outer Higgs distortion field. And yes, it's as cool as it sounds. This field, in theory, could reduce the mass of a spacecraft to practically nothing. Think of it as putting the spaceship on a super intense diet without any of the hunger pangs or grumpy moods. Now, how does it achieve this marvel of interstellar weight loss? Well, it's all thanks to the magic of advanced quantum field technology. This is where we take a leaf out of the Higgs boson's book, that elusive particle that endows other particles with mass. The Higgs field modulator could potentially manipulate the Higgs field at a quantum level, a process that's currently beyond our understanding of physics. It's like teaching an elephant to do ballet. We're not quite sure how it would work, but it sure would be impressive. So in essence, we're tricking the universe into thinking our spaceship weighs as much as a feather. And just like that, we've taken the first giant leap towards achieving light-speed travel. The future, it seems, might just be lighter than we ever imagined. Next up, we have the quantum entanglement core, which sounds like something out of a sci-fi movie. Now, this isn't just a fancy name for our popcorn machine. The quantum entanglement core has a crucial job. It manages the inner Higgs standard field, which ensures the spacecraft retains its standard mass properties within. This is vital because while zipping around at light speed sounds fun, it's less fun when your coffee cup floats away in zero gravity. But how does it work? Well, it employs a principle known as quantum entanglement. Imagine you have a pair of quantum entangled socks. No matter how far apart they are, if one sock gets a hole, the other one will too. It's a bit more complex than that, but you get the idea. In our case, the quantum entanglement core uses this principle to synchronize the ship's internal field with the normal Higgs field. This helps maintain a stable environment inside the ship, even as we're reducing its effective mass to zero outside. It's like having a personal bubble of normalcy in a sea of weird physics. A bit like when you're at a party and you find that one person who also doesn't understand why everyone else is dancing to the music. So the quantum entanglement core is our cosmic DJ, keeping things synchronized and harmonious. Think of it as a cosmic synchronization, keeping things normal when everything else is anything but. Now, all this space magic needs some serious juice to run. Imagine trying to light up a city with a couple of hamsters on a wheel. Well, powering a Higgs distortion drive is like lighting up 1 million cities with those same hamsters. It's a big ask. Enter our contenders: zero-point energy extractors, antimatter reactors, and compact fusion generators. Zero-point energy extractors could tap into the infinite energy of the vacuum itself. Antimatter reactors, on the other hand, would harness the total conversion of matter to energy that occurs when matter and antimatter meet. It's like a really intense game of rock, paper, scissors, but with a lot more energy. And then we have compact fusion generators. These bad boys would mimic the power of the stars themselves right here in our little spaceship. Fusion is the process that lights up the sun and every other star you can see in the night sky. So we're not just talking about AA batteries here. Transitioning between two fields can be a bit bumpy, but not with the field transition buffer. Now, imagine you're driving a car, smoothly cruising along the highway, then suddenly you have to navigate off-road terrain. It's jarring, right? This is where our field transition buffer steps in, acting like the most advanced set of shock absorbers ever conceived. Its function is to manage the transition between the outer Higgs distortion field and the inner Higgs standard field. It prevents catastrophic effects when switching between them, ensuring a smooth ride for our intrepid spacefarers. The sci-fi mechanism behind this? A sophisticated system of field dampeners and regulators. Picture a finely tuned orchestra, each dampener and regulator playing their part, carefully balancing the two Higgs fields. This might involve exotic materials or yet unknown principles of field dynamics. But hey, we're in the realm of speculation here. Who knows what future discoveries might unveil? It's like having the best shock absorbers for the bumpiest cosmic roads. Driving at the speed of light isn't something your average GPS can handle. This is where the navigation and control system steps in, a true marvel of science fiction. Imagine a technology so advanced, it makes your latest smartphone look like a stone tablet. First, we have an artificial intelligence, or AI, sophisticated enough to make deep, meaningful choices in a fraction of a second. It's not just deciding which route gets you to Alpha Centauri the fastest, but also how to avoid that rogue asteroid along the way. Next, we have quantum computing, the big gun in our computational arsenal. It's like the world's best chess player, constantly calculating, adjusting, and recalculating the complex field dynamics required for light speed travel. Picture juggling a million balls at once, and you're getting close. Together, these two create a navigation system that doesn't just read the map, it writes it. It's like having a super smart autopilot that also happens to understand the mysteries of the universe. At light speed, you want to be sure your ship can hold together. Now let's not forget about our precious structural integrity field. This is the unsung hero of our light speed journey. It's not just about going fast, it's about going fast without turning your spaceship into a cosmic jigsaw puzzle. Now how does it work? Picture this: a field that reinforces the molecular structure of the spaceship, possibly using hold on to your hats, nanotechnology, or advanced materials science. This field is like an invisible net, keeping everything together when the universe is doing its best to pull you apart. Imagine having an army of nanobots reinforcing every atom of your spaceship, making sure that no matter how fast you're going, your ship remains one solid piece. It's a high-tech solution to a high-speed problem. So, when you're zooming through the cosmos, remember, it's the ultimate cosmic glue keeping everything intact. Last, but definitely not least, we have the safety and life support systems. Now, this is where science fiction takes a backseat to reality. Because let's face it, we're not just trying to make a spacecraft zoom through the cosmos at breakneck speed, we're trying to keep our intrepid spacefarers alive while doing it. Imagine a system so advanced, it can independently operate from the Higgs fields, ensuring a stable and livable environment inside the spaceship. It's not just about having an adequate supply of oxygen and maintaining a comfortable temperature. It's about managing radiation levels, ensuring gravity-like conditions, and even recycling waste into usable resources. Think of it as the most sophisticated camping trip you've ever been on. But instead of packing bear spray and a first aid kit, you're bringing along cutting-edge technology capable of sustaining life in the harsh, unforgiving environment of space. Because what good is traveling at light speed if you can't live to tell the tale? So, there you have it, the components of the Higgs distortion drive. A mechanism sounding like it's straight out of a sci-fi movie, yet grounded in a blend of current science and imaginative extrapolation. We've covered the Higgs field modulator, the device that makes the impossible possible, reducing the mass of our hypothetical spacecraft to nil. The quantum entanglement core, maintaining a stable environment within the ship, despite the mind-boggling speeds outside. The energy source, a futuristic powerhouse that goes beyond our current technological capabilities. The field transition buffer, ensuring a smooth transition between the two Higgs fields. The navigation and control system, an advanced AI that steers the ship through the vast cosmos. The structural integrity field, keeping the spacecraft together under the stresses of light-speed travel. And finally, the safety and life support systems, ensuring the survival of the crew and passengers. However, this is just a speculative scenario. There are limitations and considerations we must ponder. Relativistic effects, navigational challenges, and immense energy requirements are some of the hurdles we'd face. But isn't that the beauty of science? The challenges that push us to explore, invent, and evolve. While we may not be ready to jump to light speed just yet, who knows what the future holds? After all, science fiction often becomes science fact. So keep dreaming, keep exploring, because the universe is the final frontier, and it awaits us.